Nature of physics. In this lecture we will talk about the nature, scope, and branches of physics. Before we move to the nature of physics, a few words are in order about the nature of science. Nature of science. 1. The world is understandable. Science presumes that the things and events in the universe occur in consistent patterns that are comprehensible through careful, systematic study. Scientists believe in repeatability of phenomena. As an example, the sun will rise every day and seasons will repeat. Further, the laws of science are applicable throughout the universe. If life depends on oxygen on Earth, so will it on Mars, if there is life. 2. Scientific ideas are subject to change. A given theory may explain a set of observations. It is possible that another theory may fit just as well or better. In science, the testing and improving and occasional discarding of theories is not unusual. 3. Scientific knowledge is stable. Continuity and stability are as characteristic of science as change is, and confidence is as prevalent as tentativeness. Theory of relativity does not discard the Newtonian laws of motion, it shows them to be approximations. 4. Science does not answer all questions. Existence of God, is there God, morality, what acts are moral, are examples. 5. Science relies on evidence and careful use of logic. Kepler's laws are based on astronomical observations, primarily from Tycho Brahe. Law of areas and law of periods are derived using laws of physics and logic. 6. Science explains and predicts. Explanation is explaining observations from scientific laws, theory. Prediction is the theory's ability to predict as yet unobserved phenomenon. Darwin's theory predicted common descent. All species are linked in a single evolutionary tree, stemming from common ancestors. This was confirmed by vast genetic and morphological evidence showing relationships between all life forms. 7. Science is independent of the scientist. A theory proposed by famous scientist is not necessarily true. God does not play dice is Albert Einstein's way of expressing disbelief in quantum mechanics. Many physicists supported quantum mechanics, which enables such things as the laser. In summary, science relies on observations and experiments that are repeatable, and same results are obtained no matter who or where the experiments are conducted. Some experiments involve huge costs and are supported by several countries. CERN is primarily funded by its 23 member states. Back to nature of physics. 1. Physics, being a natural science, has all the characteristics 1 to 7 of any science. It is the fundamental study of matter, energy, motion, force, space, and time, seeking to understand how the universe works. It uses mathematics as a precise language to formulate laws and theories. 2. Physics covers vast range from describing the function of everything around us, from the movement of tiny charged particles to the motion of people, cars, and spaceships. Almost everything around us can be described quite accurately by the laws of physics. Examples are smartphone, TV, microwave. Next, consider a GPS system. Physics describes the relationship between the speed of an object, the distance over which it travels, and the time it takes to travel that distance. When you use a GPS device in a vehicle, it utilizes these physics equations to determine the travel time from one location to another. The study of physics is capable of making significant contributions through advances in new technologies that arise from theoretical breakthroughs. 3. Physics is the foundation of many important disciplines and contributes directly to others. Chemistry deals with the interactions of atoms and molecules, so it is rooted in atomic and molecular physics. Engineers use laws of physics in designing buildings, bridges, cars, etc. Structural engineers use laws derived from physics to see whether a 122-story building is stable. Architects consider acoustics, heating, lighting, all branches of physics, and the cooling of buildings while designing a building. Actually, modern buildings are the joint work of engineers and architects. Architects also consider aesthetics and ergonomics. Parts of geology rely heavily on physics, such as the radioactive dating of rocks, earthquake analysis, and heat transfer in the earth. Some disciplines, such as biophysics and geophysics, are hybrids of physics and other disciplines. 4. Physics is one of the foundations of chemistry. In biological sciences it helps describe the properties of cell walls and cell membranes. On the macroscopic level, it can explain the heat, work, and power associated with the human body. Physics is involved in medical diagnostics, such as X-rays, magnetic resonance imaging, MRI, and ultrasonic blood flow measurements. Medical therapy sometimes directly involves physics. Cancer radiotherapy uses ionizing radiation, for instance. Physics can also explain sensory phenomena, such as how musical instruments make sound, how the eye detects color, and how lasers can transmit information. Models, theories, and laws in physics. Models. A model is a representation of something that is often too difficult, or impossible, to display directly. An example is the commonly used planetary model of the atom. Laws are summarized/abstracted observations. Examples are Boyle's law, Hooke's law, Kirchhoff's law, etc. Theory helps make predictions or using to make predictions, such as the satellite motion, design a laser 3D model using holography, etc. Key takeaway: no matter which discipline you are pursuing or plan to pursue, knowledge of physics helps.